morning, ladies and gentlemen. Do you know your triangles?
Our friend the triangle.
Oh, too excited. Okay. Let's talk about the parts of a right triangle, 90 degrees. The longest side is our hypotenuse.
They better know that.
Write this down too, even if you don't, write it down. The adjacent side is the side touching the angle. So angle, side touching the angle. Angle, side touching the angle.
Adjacent side.
Adjacent side. Oh, yeah.
Yep, you're right. Yep.
And then this is not the adjacent side because that's the hypotenuse.
It's the long one.
The long one, the adjacent one. The opposite side is the side opposite the angle. Angle, opposite. Angle, opposite.
Simple.
Very simple. Okay, write this down. Identify the parts.
Pause, write it in. Go ahead.
Okay, now that you're finished, you should have A is the opposite, B is the adjacent, and C is the hypotenuse.
Yep.
How we do? Ah, that's Pythagoras' theorem. Pythagoras' theorem. I'm pretty sure you guys learned about this in Sergeant's class. A squared plus B squared equals C squared. A squared plus B squared equals C squared.
Well, I wonder if they would be able to solve that for A.
Ooh, should we do that?
Would you know how to solve that for A?
How would you be able to solve for A?
Well, how would you solve it for C first?
Okay, so if we want to solve for C, should I put this up and do it here?
Yeah, sure, why not?
If I want to solve for C, oh, got some stuff left over. Got some leftovers. AP physics stuff. Next year. Okay. If I want to solve for C, I got to get rid of that 2.
How do you do that?
Squared. Okay, I'm going to take the square root to get rid of the 2.
Yeah.
And if I do that on this side, I have to do the same thing on this side.
Simple.
So C equals the square root of A squared plus B squared. This is important.
Yep.
Write that down. Maurice? Should we solve for A2 or no?
Yeah. It'll only take a moment.
Okay, let's do it.
How do you get A by itself?
Well, first we got to get rid of B, right?
That's right.
Minus B squared minus B squared. A squared equals C squared minus B squared. We got to get rid of that 2 again. How do we do it?
It's simple.
Square root, A, square root of C squared minus B squared. I can do this in my sleep.
Done.
Easy, easy. Soa, ka, toa. Your worst nightmare.
Nah.
Nah.
Your
just
calculator knows how to do it.
Yeah, this is easy stuff. So, in order to find the sine of the angle, sine theta, you just plug in the opposite and the hypotenuse numbers. Tangent, opposite, adjacent, and cosine, adjacent, hypotenuse.
That looks a lot like A is equal to B over C to me.
It is. It's the same thing.
That's all there is to it.
Challenge number 1. Without measuring directly, determine the diagonal distance across your table.
Oh, if only they were here in the classroom.
Oh, this would be so much fun.
Yeah.
Take a step over here to my table. So, we want to figure out the diagonal distance from here all the way to here without measuring directly. Okay. So the first thing I'm going to do, great. I'm going to measure this over here. Meter stick.
Yes.
And I'm going to go ahead and measure from here to here. I get 0.75. 0.75 meters. And that is from here to here. And I measured from right here, from this point, just because the edges are curved.
Yep.
So it gave me kind of a funky. Okay, now this one's a little bit longer. I need 2 for this. Uh-oh, might need more. Okay, so I've got 2 meters. Let's straighten it out a little bit. 2 meters. 2.13. 2.13.
Miss Moore, why have you measured these two things if we want to know the diagonal?
Well, we know that we can do Thag's theorem, right? And
Oh, make a triangle.
we can make a triangle, right? Okay, so let's go ahead and line this guy up. Something like that, right?
Yeah.
Okay. Dough. So we use pencils, ladies and gentlemen. Okay. So we want to figure out.
That, ladies and gentlemen, is a perfectly straight line. Perfectly straight line.
It doesn't get much better than this.
That's right.
Okay, so how are we gonna do this? What was that equation again? This is like C, right?
That's C.
This is like A.
Yeah.
This is like B.
Yep.
I might have got my numbers mixed up. This is the angle.
Yep.
Okay, let's do this. A squared plus B squared equals C squared, am I right?
Yes.
Oh, I should have just started with what we know. We know that we gotta get C by itself. I should have just taken the square root of this first. I'm not going to write this out anymore like this. I'm just gonna start with this next time. Because you guys already know how to do this. Okay, let's plug stuff in. A is 0.75 meters, don't forget to square it, plus 2.13 meters squared. And this is gonna give me C. Calculator. Okay, square root on, I did that last time. Square root 0.75 squared plus 2.13 squared.
I think you're going to need parentheses with this calculator. But
shoot.
hit equals 5. That is not 5.2 meters.
Let's go ahead and double check that. So this, ladies and gentlemen, this calculator isn't as smart as the other one, so we need to put in some parentheses. Square root, parenthesis. 0.75 squared, close parenthesis. New parenthesis.
No, you don't have to close it.
No, we don't have to close
No,
it?
just plus the other one. Because what you have to do is
Delete.
close things under the radical.
Close things under the radical.
There you go.
0.75 squared, what is it? Plus
Yeah.
2.13
Yep.
squared. And then I close this one, right?
Yep.
Close the door. Enter. 2.26.
2.26.
C equals 2.26 meters. So that's this guy right here, right?
Yeah.
Let's see if we got this right.
So we'll put this one right here.
So this is 1. This is 2. I'll be darned.
2.26.
We're close. 2.26, and that's how it's done. Oh, are we done yet?
What angle does the diagonal make with the long side?
Oh. What angle does the diagonal make with the long side? How do we do this?
Well, we could use one of those trigonometric functions.
We sure can. You know what? I'm gonna do that.
Which one would you like to use? Tangent?
Well, I'm gonna use tangent. Yeah. Okay. So we know that the tangent equals the opposite over the adjacent, right?
Yep.
Ooh, the tangent theta.
So if this is the angle, the opposite is that one over there.
And the adjacent is.
Yeah, but we don't want the tangent of the angle. We want the angle. How can we get the angle?
Oh, good question. Okay. So if we want to get the tangent of the angle, what we're gonna do is we're gonna do the -1, right?
Yeah, that inverse tangent thing.
Yeah. So we're gonna say tangent -1 opposite over adjacent
0.75.
divided by 2.13.
Where's that good calculator?
I know, where's the good one? Where's
Calculator.
the good one?
Here, calculator. Good calculator. Here it is.
Come here. Oh, hiding right by the skull. Oh, why do you
The
have
school skull.
Okay, tangent -1. Oh, that's so much easier. Look at that. 0.75 divided by 2.13. And I get 19.4 degrees.
Sweet.
Can we check this one?
Yeah. Gotta go over here.
Look at that. Oh, look at that. Now, let me use.
And put this down like this.
Yeah. Okay, we want to line the bottom up right here. Take a little bit of practice. And
That is nowhere close.
uh-oh.
Now let's see here. That. Here, hang on to it.
Mm-hmm.
Let's see here. If I look at it from down here, is that right on the corner? No, it's not. See how this is, it's not on the corner?
Oh.
It
Let's
has
go
to-
right there.
Yeah, so
Right there.
draw another line from that corner.
Like that, right?
Yeah. Makes a difference.
It does.
Yeah, closer.
Close enough. Oh, and you know what? That's right. The edge is right there. Yeah, it's a little closer.
All right.
So the idea here is that we measured the hypotenuse by measuring indirectly by measuring A and B, squaring it and taking the square root of it, and then we use the inverse tangent in order to find the angle. That last step is super important.
And remember, the inverse tangent is just a button on your calculator.
Just the button. Let's take a walk in the quad. Draw this in your notebook to the best of your abilities.
Oh, that's the quad.
Yeah. Okay, let's go outside and walk the quad. There we go. Oh, look at my.
Oh, it's a beautiful day.
It really is. So we're gonna walk from one letter to another letter.
First, you got to figure out where we are.
Let's get my bearings here. So we wanted to go from L to A first. L's right there.
Okay, so yeah, here's the
Golden
thing over there where
Valley.
Golden Valley is, and here's where the clock is. So A is there.
So it's
L would be
somewhere-
over there.
And I'm gonna count the steps that I take. Once I get in position.
All right.
Can you hear me okay with this mouth phone?
Well, yeah.
Use my teacher voice. Okay.
There's a piece of tape right there.
Oh, look at that. Ready? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21?
I call that 21 steps. So that's from what? L to A.
21 steps.
Now where are we going?
From A to B, quads like this. So
So that's
is it gonna be that middle?
in the
section right
next
there?
set of stairs right in the middle of it.
Okay, here we go. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
22 steps.
No tape this time, but that's okay. 22 steps. Make your second two look better than that. So we just walked here and here.
Yeah.
What's next? HG. H is going to be somewhere over there.
Now, H is going to be over by the
Yes.
girls' bathroom.
Yeah, okay, let's go over
All
there.
right.
Oh, in that corner right there. I
Yeah.
see it. A little divot.
Oh, it is important.
Okay. Okay. I would say right about here, right?
Okay,
That trash can.
you'll have to. Don't hit the trash can.
I gonna beeline it here. Okay, from H to G. Ready, set. 19, 20, 21. Dang, what's up with this 21 number?
Must be some symmetry at work here.
Yeah, good job, Golden Valley.
Or architect.
Yeah. Okay.
Now where are we going?
We're in the corner. We're gonna go all the way to E. Those
What's down there by the roses?
The roses. Okay, here we go. Ready?
Swimmers, take your mark.
Set. 39, 40, 41. 41.
41 steps.
Back inside we go.
Let's go back.
All right, so what are we gonna do with this data?
I know.
Like, what's going on here? Is this just an excuse to get outside?
Yeah, there's nobody asking for a bathroom pass. Plants.
Plants. All right. Woo, it feels good in here.
I'm telling you. Okay.
Where do we leave off? Come on. There it is. There it is. Vector quantities have both magnitude and direction, whereas scalar quantities have magnitude only.
What we've talked about vectors before.
We've heard these words before. We've talked about vectors.
Were those vectors out there in the quad we were walking? What kind?
So the type of vectors that we had out there were the displacement kind.
We went from that place to this place.
Yeah, x final minus x initial. Okay. Vectors are graphically represented with arrows. So the displacement, we can represent that with arrows.
We could do that on the map.
We could. Should we do that right now?
I think we should.
Okay, let's go ahead and take. Oh, look at this. Let me grab a ruler in here so I can make it. Look at all these rulers you guys could be using. 5 million rulers.
Want to sit in your comfortable chair?
Yeah, let's go over here. AP Physics. Get out of here. Okay, so
First vector was,
L to A. Oh, this is nice. It kind of gives me a little hint there.
we started at L and went
Went
to A.
Where does my arrow go?
What direction were you going?
It's walking this way.
That's right.
Okay, then I went from A to B. Do I want to make them touch?
You better. I always draw the arrow right in the heart of the letter.
Oh, that's a good idea. In fact, ladies and gentlemen, do that. Let's make a little adjustment here. Hopefully you're using a pencil. The heart of the letter. I like that better.
All right.
Okay.
Then from A to B.
My stuff's a little bit off. You guys be better than I am. So Mr. Boykin said, draw your arrow right at the heart of the letter. It should be really like right there.
All right.
And then this one right here. Now notice how I'm adding these head to tail. So here's the head of the arrow right here, and I'm
First one.
of the first one. I'm adding this head of the first one to the tail of this one.
Because that's where you turn and walk in the other direction.
Yeah, okay. And it says vectors are graphically represented with arrows. In a vector diagram, a vector arrow may be moved around, but its length and direction must stay fixed.
Okay, now we got some more, don't we?
Oh yeah, let's do these ones. So I walked from H to G, and then from G all the way to E. Oh, this is gonna be a big one. Okay, again, the head of this one goes to the tail of that one.
Okay, I think you should label these. Every arrow should have a label on it. What could we How should we label them? Probably with this stuff up here, huh?
So we can call it L to A.
Yeah, and
then we put our 21?
steps. Yeah.
Okay, so we're gonna go L A. And I'm just gonna say 21. Can you guys see that okay in there?
I can.
Okay, good. Okay, A to B. 22.
So that's how you draw and label a vector. 22 what?
Ooh. Steps.
Okay, and what about the other ones?
No. So this is H to G.
Yep.
21 steps. And here we have G to E. 41.
Okay, now vectors, how are vectors different from scalars?
So these vectors, they have direction.
Okay, and you've got this here in the corner, so we need to put a direction on each one of these.
That's a really good point.
So that's north.
Let's go. This is north, east, south, west. We'll go north like that.
So that first one, then what direction is that?
West.
That's 21 steps west.
And then
That's south.
south again. West again.
Easy.
Sweet. Okay. Let's see. What else do we have up here? We'll come back to this. Vector addition. Vectors are added head to tail. We just said that. The answer is a vector called a resultant.
So when we were walking out there, we were adding vectors because just like you said, the head of the first one was at the tail of the second one.
Exactly. Now, didn't we also do something with vectors earlier?
I guess.
Couldn't we add in some vectors over here? I could do the same thing. I'm just gonna go ahead and freehand draw it. So we started over here, kind of like we did. Okay, walk this way, 2.13 meters, whatever, right there.
There's one vector arrow.
And then I have to add this one to the head of this one, head to tail, head, tail. Okay, then what does it say up there? The answer
Is a vector called a resultant. I think the next slide tells us something about the resultant.
Okay, let's keep going then. Don't jump the gun here, Ms. Moore. Too excited. Oh, nice, you're right. The resultant is drawn from the tail of the first vector to the head of the last. Tail of the first, head of the last. That looks like C.
It do.
So, tail of the first, all the way up. Oh, I'm just gonna draw it. All the way up here, to the head of the last. Boom.
So-
Resultant.
That's how you add vectors. It's simple.
It's that
It's
simple.
just arrows.
Arrows, baby. Let's go ahead and add these vectors head to tail as well. So, I'm sorry, not head to tail. Let's go ahead and draw our vector, our resultant in here. So we start from the head of the first, the tail of the first, the head of the last. So this is gonna go like that, right?
Okay.
Can we calculate this?
Well, that's a hypotenuse, isn't it?
It sure is. So we could do a squared plus b squared and get c squared. So c equals the square root of a squared plus b squared. So that's going to get me, I'll just say a squared is this one right here.
21 steps.
21 steps squared plus 22 steps squared. Oop, squared, not S, Miss Moore. I've got my good calculator. Good looking out, Mr. Boykin. Square root 21 squared plus 22 squared equals, and I get 30.4 steps.
Huh. 30.4.
But what direction? We'll come back to this.
We'll come back to that one.
Okay, because these ones both had direction.
Yeah.
Okay, let's finish up over here. Okay, so the tail of this one to the head over here, tail of the first, to the head of the second. Ooh, could we, oh, I was gonna say, could we measure this?
Well,
I know, we didn't use
you're in
meters.
steps.
I know, like, do we have a ruler for steps? Not yet. C equals the square root of a squared, I'll just say this is a squared, plus b squared, 41 steps squared, and I get square root 21 squared plus 41 squared. I get 46, 46.1.
I wonder if this stuff works. I wonder if you went out in the quad and counted steps, if it would be right.
Let's go check.
Let's try it.
Do it. Let's check it out.
By the way, although the kids aren't going to be seeing this today, this morning was the autumnal equinox at 6:30. Ready?
30.
And how many was it supposed to be?
30.4.
Well, I'd say that worked.
Yeah, that one checked out.
Yeah,
100%. I forgot my mask.
that's all right. Take it. On your mark, get set, count. What was it supposed to be?
46.
Woohoo!
No, I'm not gonna lie. My stride was a little bit long in the beginning. I was really juiced. When you said, "All right, get set," I was like, whoosh. So
Well, it's not like a meter stick that's always the same.
I know.
The length of your stride changes.
Yeah, depending on how excited you are to be done with the lab.
Boys and girls who wish you were here today, you could be out here in the quad doing this yourself.
This could be you. A million. Right. What are we gonna do next? What direction are we going?
Ooh, okay, we got to get out the navigator's compass.
Ah, feels good.
Oh boy, that is nice.
Navigator's compass. Don't we have one of those? You just mean one of these guys? Where is it?
Should be
There they are.
right there. Well, how many degrees in a circle?
360, right?
That's right.
Which direction is this facing or pointing?
Well, in my experience, students will say northeast.
Yeah, they say it's between the north, it's in between north and east, so it must be northeast, right?
Yeah, but it doesn't look like it's exactly halfway, does it?
Don't we have a bigger one of these?
We do.
There we go, that's what I want.
There you go.
If let's see, where's it at? Where's the zero? Right there. If I line this up right here, let's see.
It's about 55 degrees.
Yeah.
See, if
between-
this
in
is
between
0 up
50
here,
Yeah.
and that's 55 degrees, northeast would be 45 degrees.
Yeah, it would be right here in the middle, but it's not. It's 55. So, how do we talk about direction?
Well,
The resultant represents the sum of all the vectors. Okay, we know that we just did that. We added up our stuff. It is the single vector that can replace two or more vectors. So it's almost as if the resultant, represents those two vectors.
yeah, it's an answer. It's like the answer to an addition problem,
Yeah.
except you're adding arrows.
Yeah. Okay, in this course, we will only be encountering 90-degree vector triangles. So, like this, 90 degrees.
Yep, right triangle.
This allows you to use Thag's theorem and SOHCAHTOA to find the magnitude and the direction of the resultant, which we haven't talked about yet, but we'll get there. Okay, so here's how we do this. Did we want to talk about the direction yet, or should we just wait?
Well, no, I think now would be a good time
Yeah.
to do the direction because we've got a sketch of the diagram here on the map.
And
we've already-
and we know how to do the tangent -1.
And we've already done the Pythagorean theorem. Now we can find
The angle.
this angle, and that angle.
So let's do the math, and then we can check our work, right?
All right.
So how did we find the angle again?
Well, first of all, you got to say where the angle is.
Well, we're starting from here.
Yeah. So,
So
it'd be that angle.
this angle right there.
Yeah.
Now we know the tangent -1 is going to give us the answer here.
Yeah.
So tangent -1 of opposite over adjacent, which is going to be, what's my opposite?
Looks like 22 steps.
22. I'm going to go ahead and I want to write it again. Tangent -1 of 22 divided by 21. What's that going to get me? Tangent. Oh, on works better. Tangent 22 divided by 21, and I get 46.3.
So that angle right there is 46.3, but that's not the direction.
It's not.
We need to, that's the internal angle.
So
We need to resolve that to the reference direction.
we were talking about north, east, south, west. Oh yes, just like that. Okay. So let's go ahead and put this right here.
No, that's upside
No, it's upside down. Oh, there we go. There we go. You're right here. Okay, let's go ahead and put this on there. So, we said it was 46 degrees, right?
Yeah, and south is 180,
Yeah.
so it'd be 180 plus 46.
Uh-huh. Wait, let me go ahead and show this. So we know that from north to south, it's 180.
Yeah.
And then, well, we know that this is 46.
Oh, that's 46 right there.
So, okay, well, what is this going to be? We have to do 90 minus 46, right?
Or we could do this, 200 and whatever that is.
270 minus 46, right?
270
Let's
minus
do that.
46 is,
Because this is 270, we minus 46. 270 minus 46.3. Let's just do it now. 270 minus 46.3. And I get 223 point.
which is about what that says right there.
Yeah.
That's right. No, lift her hand up.
Oh, right here?
Yeah, see, it's 223 degrees. Whoops, I moved it. It was right on it.
Right there. Oh, yeah, right here.
Yep.
Right there. 223. Okay.
Trigonometry works.
Woohoo! So our full answer is going to be 30.4 steps at 223.7 degrees.
Yep.
Now for this one. Pause the video, see if you can try it yourself.
Okay, which angle do we want first?
So we started here.
You want that
walking
angle.
way.
What side is that 21 steps? What part of the triangle is that?
This is the adjacent.
It's touching the angle, and so this must be the,
Opposite. So I'm going to go ahead and do it up here. Tangent -1 of the opposite, 41, divided by the adjacent, 21, gives me ooh, 62.9. But let's see where we're at here again. So we are, again, this is 80, that's 270.
yeah, but we're more than 180, see? 'Cause
Or
this
more,
angle's more
okay.
than 180.
So 180 plus whatever that was, right?
62.9.
So I can just say plus 180. You guys, you have to take a step back and really make sure you're
I'm
adding
going to
right.
say it should be right. Go, you do that. It should be right around 240 something.
Look at that.
Woohoo!
242.
See, because that's what the compass is telling
Yeah,
us.
right there. So we're gonna call it 243. And you guys know that the rounding, I won't mark you down for that because we have not practiced it. I haven't taught you about sig figs. Okay, 46.1 steps at 243 degrees.
So that's the vector, resultant vector, that's the magnitude and direction.
That's what we need. We need them both. Okay, now let's do some practice. Step one. Well, this is how we're gonna do all of these questions. Would you guys write this down in your notes? You need this. Sketch the vector. Sketch the vector diagram. Use Thag's theorem to find the magnitude of the resultant, that's just the magnitude, and then the inverse tangent to find the angle, and then resolve to reference direction. Resolve to reference direction, that just means that you might have to do some extra addition or subtraction to get the correct angle.
That's right.
So have this written down and let's rock and roll. Oh, example problem. Add these two vectors. Ladies and gentlemen, pause the video. See if you can do this. See if you've got what it takes.
Draw a compass rose up over there on the left, north, south, east, and west.
Start with that. Okay.
And what are the numbers that go with it?
Ooh, excellent point. Do you start with 0 up here?
0,
0, 180, 90,
270.
270.
Now that 0 is also 360 if you go all the way around, but we just call it 0.
Add these two vectors. 4.5 kilometers at 270 and 6.4 at 180.
270, where is that on a map? Up, down, left, or right?
Left, baby. That way. So I'm going to go ahead and draw this like this. Okay, so this is 4.5 kilometers.
Yep, at
At
270.
And again, I got that because 270 is right here.
Yeah, include the direction in your label.
Oh, good idea. West. Actually, I'll say at 270. They are the same thing, but
They are the same thing. And then,
6.4 kilometers at 180.
what direction is 180?
Down
South.
here, but we have to add them head to tail, right?
Head to tail, that's right.
Okay, this one's a little bit longer. 6.4 kilometers south or at 180 degrees.
Okay, we got our sketch. What do we do next?
What is next? We have to use Thag's theorem to find the magnitude of the resultant. Now, we start for our resultant, we're going to draw it from the tail of the first, the head of the last.
Boom.
There it is. Where's our angle?
It's a good question. Where'd you start?
We started here, so our angle must be here. Okay. Use Thag's theorem. I haven't done that yet. So this is like a squared plus b squared equals c squared. This is going to equal the square root of a squared. And it doesn't matter which one is a.
Nope.
It doesn't matter. Plus b. When I do these two, when I add these two up in the calculator, I never have my calculator. We calculate in every position of the room. Square root of 4.5 squared plus 6.4 squared, and it gets me, I get 7.82. Okay.
Golf ball.
Jesus.
Gravity.
7.82 kilometers.
And that makes sense. It's longer than the longest one.
Yeah. Are we done?
Step 3.
Use the inverse tangent function to find the angle. Okay, I know the inverse tangent is tangent -1 to find the angle. Tangent -1, opposite over adjacent.
Which one's the opposite? That's it.
Opposite over adjacent. Let's plug this in. We're almost there. Tangent -1, 6.4 divided by 4.5. I get 54.9.
So that internal angle is 54.9.
So that's this right here.
Are we done?
Not yet. So I I don't know how you like to do it, but I kind of like to think, okay, here's my compass, right?
Yeah,
And we know this is 180.
yeah,
This is 270, right?
that's 270.
So we want to know this angle, right?
Yep.
So can't we just do 270 minus this?
Yeah, because it's less than 270.
Yeah, 270 minus 54.9. Just more uses the calculator. 270 minus 54.9. 215.1.
And that's the direction.
This is the direction at 215.1 degrees.
Whew.
Done.
Yep.
And that last thing that we did, this math here, that's what I mean by resolve to reference direction. That extra step. Oh, we just did that. Whew. Okay, I was like, another one. Oh, and there it is. Right? It
Yep.
looks like that.
Yep, the answer should be like that.
And this makes sense. 215. Here. This is 215.
Yep.
Oh, wrong way.
Nope, we're not going to do that.
Done.
Done.
Paused.